Welcome to my video series on being an applied statistician using JAMOVI. In this particular video, we're going to deal with the paired or dependent or repeated measures t-test. Okay, let me just turn on my laser pointer here. Okay, so the first thing we're going to do is we're just going to go through the statistical test decision tree and just see where the repeated measures or paired t-test actually is situated. So first of all, as always, we start from the design analysis research question. A t-test, independent or dependent, is a test of difference. It's used when we have interval data. It's also used when we have normally distributed interval data. It's also used for two groups. However, it's used for two groups when the same participants give both measures. Therefore, it's called a repeated measures, or if you like, a paired t-test. So that's where this test is actually situated. Test of difference, interval data, normally distributed, two groups, repeated measure. Okay, let's now explain what that actually means. So when do we actually use the paired t-test? So please consider the following research question. Is there a difference in the level of anxiety students have about writing before and after completing a 101 writing course? So in this research question, we have one measure. The measure is level of anxiety. However, the students are evaluated on this measure before taking a writing course and after taking a writing course. And what interests us, of course, is there a reduction in the level of anxiety? We would hope that having taken a writing course, you would be less anxious about your writing than before taking a writing course. That is what we would hope. However, that is not necessarily what is true. So this is something that we need to test. So let's go through the analysis of this question. Do we have a grouping variable? Well, we do. In this case, we have time. So we have before the class, that's one measure, and we have after the class, and that is the second measure. Number of groups that I have two groups. I have a before group and I have an after group. Are the groups independent? Remember, this is the question. If they are independent, we would use an independent t-test. If they're not independent, if they're paired or it's a repeated measures, we would have to use a paired t-test. In this particular case, we have to answer no, they're not independent, because the definition of being dependent or independent, if you like, not independent, is that the same students were in each group. The same participant gave the first measurement as the second measurement. Therefore, they're paired. We're pairing the two measures. And in a minute, I'll show you what this means in a more schematic way. We have an outcome variable. We have an anxiety level. It's a 5-point scale. 1 equals high anxiety and 5 equals low anxiety. The outcome variable data type is interval, is continuous data. So we need a test that compares two paired groups of students without one outcome variable. Let's take a look at this schematically. So if we look at this diagram over here, we see that we have one set of participants. It's not like the independent t-test where we have two groups of participants. What we have here are two measurements times. So this is the measurement, in our case, before the class on the anxiety level. And this is the measurement after the class, also on the anxiety level. How does the paired t-test work? So we collect the results for participants for time 1 and for time 2. We create a mean for time 1, a mean for time 2, and the paired t-test compares between these two means. When can you use the paired t-test? So there are several conditions. First of all, the main aim here, when you want to compare the mean of two measurements of the same participant to see if they are really different. So your aim is to see a difference between two measurements of the same participant. The test assumes that the same participants gave both measurements. I will show you exactly what this means in a spreadsheet very shortly. You can only compare two variables at a time. If you have more than two variables, we have a different type of test for that. And the t-test assumes that the data is normally distributed. We have basic hypotheses for the comparison. We have a two-tailed hypothesis. This is a general claim of difference. The null hypothesis is that the two measurements are the same. The counterclaim, the alternative hypothesis, is that the two measurements are different. On a one-tailed hypothesis, we have a claim of direction. The null hypothesis is still the same, that the two measurements are the same. However, the alternative hypothesis is that one measurement is higher or lower than the other measurement. And with that, we're going to move over to the paired t-test in JAMOVI. So as you can see, I've opened up JAMOVI, and I've opened up JAMOVI on the start page. And let's start by just looking at the two variables I have here. Remember, our research question dealt with this issue of the level of anxiety a student had before taking a writing class and the level of anxiety they had after the class. So I have here two variables, anxiety before and anxiety after. Let me just double click on this as I always do. So the name of the variable is anxiety before. The definition is student anxiety level before writing a class, and this is a continuous variable. Close that. The other variable, the second variable I have is anxiety after, and this is the anxiety level after completing the writing course, and this also is a continuous variable. Before we enter into the analysis, let me just point out one very particular thing. Let me explain what paired actually means, or what repeated measures actually means, in a very simple visual way. So this number over here, 1, 2, 3, 4, these are students, right? So this is student number 1. Anxiety before, this 4 is the measurement he gave at the beginning, before the course. And this measure number 2 is the measure he gave after the course. So what's important here, this measure and this measure, this 4 and this 2, come from the same participant. It's very important when we have a paired or repeated measures. So he did it once and then he repeated it afterwards. What's important about this is that they are on the same line. And as you'll see shortly, this is how we enter the data into the analysis. So with that, let's go to the analyses. We go to t-test and we go to paired t-test. And this opens up this dialog box. So the first thing we do is we enter our variables. So we have a before variable. Let me put that in. And you'll notice this line appears over here. I press for the after variable. And this is my pair, before and after, anxiety before and anxiety after. Okay, so what do I want to do here? Well, the first thing I want to do is I want to test normality. So let's just click on this. And you can see that this immediately comes up. The normality test is a Shapiro-Wilk test. What I'm interested in is the p-value. Is this p-value above 0.001 or is it equal or below? If it's equal or below, we're going to say that this is not normally distributed. But in this case, it's 0.132, way above 0.001. We're going to assume that this is normally distributed. Okay, the second thing I want to do is I want to look at the descriptive data, and I'm also going to have a descriptive plot, which I'll describe in just a second. So this is the table for descriptives. I have anxiety before and anxiety after. The variable I'm interested in is the mean. And I see that before I have a mean of 3.6 on my anxiety scale, and after I have a mean of 2.15. Remember, one means less anxiety, 5 means more anxiety. So we have a reduction of anxiety. This distance looks pretty big to me, so I expect this to be a significant difference. If I go down here to the plot, what you can see is this is the anxiety before, this is the anxiety after. The dot in the circle in the middle, that's the mean. The square is the median. We're going to ignore the median at the moment. And you can see that there's no overlap between the confidence intervals, these two markers here. That usually designates that there is a significant difference, not always because of the way this particular plot is calculated. Okay, now let's go over to our hypothesis. So what is my hypothesis? I could have a hypothesis that they are just different, the so-called two-tailed, but actually I have a quite directed one-tailed hypothesis. I assume that the level of anxiety will be reduced, that it will go down. So I assume that measure 1 is going to be higher than measure 2. So this is what this looks like. Measure 1 is going to be higher than measure 2. With that, we can now go and look at our actual test, the pairs sample t-test. So here I have the test statistic as 5.08. Here I have the degrees of freedom, which is 19. And finally, I have the p-level. The p-level is 0.001. This is way below 0.05. Therefore, we have a significant difference between the before and after variable. The last thing I want to do here, I want to check effect size. This is done with Cohen's d, and you see it comes up here. Once again, I remind you that effect size relates to the practical significance of the result I've got. 0.2 is a weak effect, 0.5 is a medium effect, above 0.8 is a strong effect. Here I have 1.14, that's a very strong effect. So I have a good result here for my study. So what is my conclusion based on this data? My conclusion is that anxiety after writing a course does indeed reduce. I do have less anxiety at the end of a course than I do at the beginning of a course. And with that, what's left for us to do is to report our results. So this is how we report a paired t-test. Let me read the full language and then we'll go over it together. In the paired t-test, there was a significant difference in the rated level of writing anxiety before and after completing a writing course. There was a strong effect size. So as you can see, as we did in the independent t-test, you do need to provide the mean and the standard deviation. Remember, we're comparing this mean to this mean. So you can find this in the descriptives table. This is data. This is just the output on the right side in the JAMOVI window. So we have 3.6. The standard deviation is over here, 1.142. And we do the same for the after variable, which is the one that's just below. Now, where do we find the t-statistic? So this is how we report the t-statistics. This shows us that this is significantly different, of course. So 19 is the degrees of freedom that we have here. A 5.08 is the actual t-statistic, and this is the significance level. And finally, we are reporting the Cohen's d, which is the effect size, and that you can find over here. So when you report a paired t-test, this is the language that you should use, and these are the statistics and the test statistics that you need to provide for your reader so that they can follow through with what you're doing. I hope this video has been useful for you and is useful in your research and in your studies, and I look forward to seeing you in my next video.